Okay, we're going to sketch a hyperbola. So first we have to find the standard form of the equation. So we have x squared, and we have 2x. And the thing that would go well with the 2x is a 1. I complete the square, but I better add 1 to the other side. And then let's see, what do we got? We have negative 9. Well, that won't do, so I'm going to factor out the negative 9, and I have y squared. And I factor out the negative 9, and I get plus 6y. And then I say, half of 6 is 3, squared is 9. So I'm going to add a 9, but wait, I'm not really just adding a 9, I'm adding a 9 times 9, actually a negative 9 times 9. So on the other side, to make up for it, I'm going to subtract 81, since I really just subtracted 81. Looks like I added 9, but I really subtracted 81. And let's see, while I'm at it, let me add 80 to both sides, while I'm at it. And I say, wait a minute here. It's equal to 0. What? It's equal to 0? Well, yes, it's equal to 0, which means it's degenerate. And I have a big problem. So in the interest of going ahead and sketching a parabola anyway, let me just make up something. Let's see if I can make up something. So normally we'd stop there and we'd say degenerate, because we're Puritans and we disapprove. No, that's just the name, a degenerate conic. But we want to keep going, because what's the good of an example problem if it doesn't actually work out? So we're going to new problem. We're going to say new problem down here. And let's think of something nice. We don't want to do something rough. So what could I divide 9 by? I could say it's equal to 81, huh? That would be nice. I need something that's a nice square that's going to work well with 9. So let's just say it's equal to 81. Okay, I know it's not. We're done. Problem's over. But what if yours is not degenerate? What if you need an example? Okay, well, here's our example for you. We're dividing everything by 81 because it's supposed to be equal to 1. So now I have x plus 1 squared over 9 squared minus the 9 cancels, and I get y plus 3 squared. 9 cancels, so that means 9's on the bottom, so I have 3 squared on the bottom equals 1. So there's a nice, serviceable, what are we doing? Hyperbola. Yes. Okay. It's hard when you make up things. Okay, so our h is equal to minus 1. You can see it's minus 1 there. And you can see our k is minus 3. So k is minus 3. Our a, which is underneath the not negative 1 is what I was trying to say. Not negative. Yeah, so that's 3. No, it's 9. 9 squared. And our b is equal to, right there, 3. Oops, sorry about that. 3. So we're supposed to, what are we supposed to do? We're supposed to find the center. Well, the center is minus 1, minus 3. That's the center. Maybe I shouldn't use the letter C. That's too confusing, isn't it? Sorry. My apologies. We will say the center. Cent. I'll just say cent. The center. And let's see. We're supposed to find the vertices. All right. Well, maybe it's time to graph this puppy. So minus 1, minus 3. I guess we'll do this right here. And we'll say it's horizontal. So we'll say minus 1, minus 3. Say that's right there. That's our center. And then, wow, it's 9 out. So, I don't know, what is that? Does that look like 9 to you? About right there? And about 9 right there. We'll call that 9. So let's see, we were at -1, so this is 8. This is -1, and this will be -10, right? Okay, so there's our vertices, and oh, by the way, we're at -3. So our vertices are 8, -3, and let's see, -10, -3. Okay, and then I think they want the foci. Yes, they do. Of course, they want the asymptotes. So let's see, the foci. For the foci, I'm going to have to say c squared is equal to a squared and b squared. And because I have a negative sign there, I'm going to use a positive because I always use the opposite. So I'm going to say positive. So c squared is equal to 9 squared plus 3 squared. And c is equal to the square root of 81 plus 9, or the square root of 90. And let's see, the square root of 90, what is that about? Well, 9 times 9 is 81, 10 times 10 is 100. So what would we say here? I guess I'll bow to my calculator, see what my calculator says. The square root of 90 is 9.5. See, that's what I'd have said anyway. I should have just gone with my gut. 9.5. Okay, so we notice, to our pleasure, that it's a little further, and it should be for hyperbola. You see, I'm not going to have room to draw my hyperbola, right? But anyway, 9, it's not much bigger, is it? It's just a little bit bigger. And it's just a little bit bigger. Not much. Kind of silly. So it must be a pretty tight hyperbola. The asymptotes must be pretty flat. That's what I'm guessing. Maybe I'm wrong. Stay tuned. Let's see. So we have the foci. What are the foci? The foci are, 8.5, because it was 0.5 more, and -3. And the foci is the focus over here. If I'm going to talk about one, -10, that's no good. -10.5, -3. All right, now I would like to draw my asymptotes. So I'm thinking about B. B is 3. So what color should I use? I kind of hesitate to use. I guess I'll go back to red. I have my B up here. It's 3 away. You know, that doesn't look like it's really 3 compared to 9, but anyway, there we go. Here's our -6, and then, okay. So we're going to draw our rectangular box here. Okay, x-axis time here. And let's go ahead, and this is going to be quite a stretch here. Can I keep my hand moving in the appropriate way? It's going out here. Keeps going in the same direction. That's the stipulation. It has to keep going in the same slope. So here we go. I'm going to try to keep it going. I'm sketching. This is called sketching, you know. Are we perfect? No. But we're trying. So here we go. It is going to be a pretty flat asymptotes, as I predicted, as you could have seen coming. So let's see here. Well, there we go. We'll try not to mess up our other work. Okay. But the fact that the focus on each side was so close, we knew it couldn't go too far out. It couldn't be such a big, wide, fat expanse. It'd have to be pretty skinny if the focus is going to be that close to the vertex. Okay, the foci and the vertices. Okay, so we sketched it, and we drew the asymptotes, and they want the formula for the asymptotes. Well, yeah, I guess we could do that, and I may do that after the video. First thing is that the slope of the asymptote is going to be equal to positive or negative. Since they're horizontal, it's b over a. Okay? And then we're going to say that they have to go through -1, -3. So if you remember this, the slope, or the formula, is going to be positive and negative, one time one way, one time the other way. X minus h, so x plus h, and then plus k. Okay, so k is -3, so I should have said -3. And then, of course, as I plug in b and a, I can find, I'll go ahead and do it. If I've gone this far, why not? I have 3 over 9, so that's 1/3, x plus 1 minus 3, so that's equal to 1/3 x plus 1/3 minus 9 over 3, so we're going to say minus 8 over 3, and we'll say y is equal to negative 1/3 x plus 1 minus 3, and now we have negative 1/3 x, negative 1/3 next, so that's negative 10 over 3. And so these are the lines of my asymptotes. And if that was something that really interested you, that's fine. And you know, we know it doesn't cross at 3, but it crosses really close to 3. Here's 3, and both asymptotes miss 3 by just a little bit, one to the north and one to the south, but those intercepts make sense, and one's going down, one's going up, so the slopes make sense, so we're good. Okay, so anything else they wanted from us? Oh, we'll verify the graph. In the next video, I'll show you the verified graph.